I was a little kid, I wanted to be an ocean scientist. We moved to the state of New Hampshire when I was like 6 years old from the Midwest. I was fascinated by the ocean and just wanted to be an ocean scientist from that point forward. My focus is igneous rocks erupted along the global mid-ocean ridge system, which is the most volcanically active place on the planet. So I study the origin of igneous rocks by understanding aspects about their mineralogy, texture, their chemistry.
It's a great point. All of these discussions are really crucial because these are real things.
So I teach the Earth and Space Science class. I've done it collaboratively with the astronomy department each time.
You know, if you make a data set, you know, for the kids to plot, it's going to be probably a little messy, you know, and that's the reality of working with data. I know I forced you guys to work with messy data before. You didn't like me for it, I'm sure, but it's the reality of data. I understand, you know.
I want all of my students, whether they be teachers or undergraduate students or whomever, to have a great learning experience in my class. And understanding the audience that you're working with is an important part of making that happen. Teachers are really expert learners already. Okay, so they know a lot about education and learning and how to learn, but they tend to be more content novices. You know, there's this crazy misconception that the lower grade level you're teaching science content at, the less you really have to know about it. And my experience is the actual opposite is true. With the earth sciences in particular, the knowledge kind of builds on one another. And it's really important to understand kind of like the big picture, to have the big picture in your head. But if what you're getting are incremental bits of knowledge and they're not connected to the big picture, then it's very, very hard to kind of really understand what's going on. If you don't have content background and you have to teach a unit on rocks and minerals, okay, so rocks and minerals very important for the elementary school standards here in Florida, right, 4th grade standards. So if you have to teach rocks and minerals, okay, you may not have to teach plate tectonics, but to answer the question, why don't we have igneous rocks in Florida? You have to understand plate tectonics. Okay, plate tectonics is more middle school, high school appropriate curriculum. And so that's another way that we are trying to approach this class, is because the content all builds on itself. It all becomes relevant to the teachers no matter what level that they're teaching it. Whether it's helping them understand more deeply something they're directly teaching, or by looking at that thing, or understand it more deeply by understanding the broader way that the earth works. It's all going to help build more confidence and more ability to kind of look at the content. One thing that I think every student of earth science can take away, no matter what level they're approaching the subject matter, no matter whether they're middle school students or teachers or undergraduate students, is an ability to be a better observer of their environment. As you learn more about the earth sciences, it just makes all those things better. You know, when I go to the beach, it's better now. You know, when I go hiking, better. When I read about a sinkhole opening up somewhere, I understand it more, right? When some issue like fracking in Florida comes up, better. So there's lots of things that, that are earth science related that we actually interact with all the time. And if you know a little bit about it, it can help you be a better observer of your environment. And once you're a better observer of your environment, then it gets the ball rolling.